everyone. Welcome to Learning at 11th Hour. So, today we are going to continue with another very interesting analysis method, which is called the concept of supernode. Now, this concept is used in circuits that have voltage sources, and these voltage sources could be connected between two non reference nodes or between a reference node and a non reference node. Now, when you consider a supernode, that particular supernode will not have a nodal voltage of its own, and it's usually applied in a circuit because we are not sure as to what is the current that is passing through a voltage source. When that dilemma arises, we go for the concept of supernode. Let's look at this example to get a clearer picture. Now, there could be two cases as already said. The first is when a voltage source is connected between the reference node and a non reference node. So, that would be in case of this particular 5 volts voltage source. So, here the 5 volts voltage source is connected between node N1 and the reference node. I'll call it as N4. So this is the first case. In that case, what is done is the value of this nodal voltage V1 becomes the value of the voltage source that is connected to it. So that means V1 becomes 5 volts. In case of the second scenario, the voltage source is connected between two non-reference nodes. So that would be node N2, and I'll call this as node N3. So when there is a voltage source connected between two non-reference nodes, in that case, we put together both the nodes and consider it to be one supernode. If there were to be any elements connected in parallel to it also, that would enter into this encapsulation and be considered as a supernode. Now, as far as a supernode is concerned, we know that it doesn't have a voltage of its own, and we can apply both KVL and KCL for the supernode. So, let's go for applying KVL for the supernode. So, here initially we need to mark the voltage drops as is usually done in case of applying KVL. So this is the first drop. We know that I3 is the current coming out from N3. So this would be the direction of drop in the 20 ohms resistor. Since I2 is flowing through 10 ohms in the downward direction, this would be the drop direction for the 10 ohms. Now considering an arbitrary drop direction in the clockwise manner, we can now write the KVL equation as 10 volts plus 10 plus V3, because after all, the drop across this 20 ohms is nothing but V3 minus 0 volts. That is the voltage at the reference node being 0 volts. V3 minus 0 is the drop across this 20 ohms resistor. So therefore, I can say V3 is this drop. So it is plus V3. In case of 10 ohms resistor, it is going to be minus V2, because after all, the drop across 10 ohms resistor here is V2 minus 0. So all this put together for the KVL, the Kirchhoff's voltage law says that put together the algebraic sum of all the drops and rises is going to be 0. So we have minus V2 plus V3 is equal to minus 10. This is the first equation. Now, if we apply KCL at the supernode. So when we go for KCL, let's look at the currents that are entering the entire supernode. So we have the three currents, I1 which is entering, so plus I1, I2 which is leaving, so minus I2, and I3 is also leaving, minus I3 is equal to 0. Now let us write I1 in terms of the voltages V1, V2 and V3 that we know. Now what is I1? I1 is the current entering node N2. So we can write I1 as V2 minus 5 divided by 5 ohms. V2 minus 5 volts divided by 5 ohms. And there is no minus sign because the current is entering this node. So it is plus. In this case, this is minus of what is I2? I2 is V2 minus 0 by 10, which is V2 by 10. Again, I3. What is I3? Minus of V3 by 20. So V3 minus 0 by 20 or V3 by 20, which is all put together to be equal to 0. So this becomes my second equation. In both of these equations, we can actually see that uh, the two unknowns are V2 and V3, and we have two equations too. So on solving these two simultaneous equations, we can get the value of V2 as 4.28 volts and V3 as minus 5.7 volts. Now, if we notice in this equation, I have said I1 is equal to V2 minus 5 volts divided by 5 ohms. Actually, it would be V2 minus V1 by 5. But since V1 is equal to 5 volts, we can directly write it as V2 minus 5 by 5. So that is the advantage of considering this particular case 1 for this circuit, right? So considering this to be a super node. So in this manner, we can simplify some really complicated circuits containing voltage sources in it. So I hope this concept of super node is clear to you all. So that's it. That's all with today's video. So today we just discussed about the concept of supernode and a simple example associated with it. It might look simple, but it's a very useful technique. Please subscribe to my channel to keep watching more such videos on circuit theory. Thank you.